Hey everybody, this is Larry. This is day 14 of the Leetcode Daily Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's problem, Palindrome partitioning. So I do self and look at these problems live, so if it goes a little bit slow, just watch it on 2x or something like that. And my thought, usually I try to go through my thought process and not just give you the solution because, well, frankly, you can there are a lot of places on the internet to just get the solution. So, okay. And that said, given a string S, partition S such that every substring is a palindrome. Okay. Okay. Well, the first thing I would notice is that n is less than 16. To be honest, I don't know if there's a better algorithm in general, but given that S is equal to 16, we can definitely do something recursively. And exhaustively. And why do I say that? The thing that because then the worst case is that, okay, let's say you have a string of 16 characters. I have to count this. All right, let me just use numbers, though I know that this is an alphabet, alphabet input. But the reason why I know that giving n, I know it immediately that I'm going to do it exhaustively in some way is because that how many ways are there to partition it? Well, the math is pretty trying to find a mathematical word for it, but I can't. But basically, we can reconceptualize these as the for each digit or each character. We could conceptualize the space between the buckets as well. We could visualize the space in between as a bucket. There you go. Sorry, these recordings are done at 3 a.m. So if I'm a little bit tired, that's my excuse. I'm sticking to it, but it's okay. And I actually expanded out, 10, 11, 12, 13, 14, 15. I know that technically I had just 0, 1 to 5. But yeah, now you can see the spaces in between, right? And what this means is that in between, well, for each of these spaces, well, you could either choose. You have two decisions to make, right? One is, okay, let's put a partition there, meaning that we could partition this as a palindrome. Let's assume that they're all palindromic, or let's ignore the palindrome part for now. But yeah, you could, given this bucket, we could choose to put in a partition, or we could not choose to not put in a partition, right? So that means that there are two possibilities for this. And then now we go to the second underscore, the second bucket. Again, there are two possibilities for this. We either draw a partition or we don't. So if you're well-versed in math or just been doing Leetcode enough, you'll probably recognize this pattern is that, okay, there are two... I should have done this a little bit cleaner, but... Sorry, let me draw this out real quick. So yeah, so this is easier for me to edit. But yeah, you play with combinatorial problems, then you realize that there's two ways to do the first one, two ways to do the second one, two ways to the third one, two ways to the fourth one, and so forth, right? ... And in total, with 16 characters, there's going to be 15. Oops, how did that happen? 15 buckets, and with the 15 buckets, each of them having a power of 2, that means that there are actually 2 to the 15 number of possibilities altogether. So 2 to the 15, when you plug in the calculator, it's about 32,000. So that's going to be, so that's going to be way fast enough, even if we do something funky. I'm going to do some pre-optimization just because it makes me sleep better, because I don't know, it looks yucky otherwise. And the pre-calculation I'm going to do it for this problem is just making sure that the the bits are the substrings are palindrome, right? Because you can do this thing where you do this recursively, and every time you go you do a recursion, you do a thing, but then you have to make sure that the last string you added is palindromic. And if you do it every time, the computation adds up, and it actually usually adds in a lot more complexity. But if we do it beforehand, and then we have an O1 lookup, then we can better bound our worst cases. So that's basically what I'm going to do. And as I said, because we do this, and we're able to, the number of substring in a string in general is just n squared, because there are n ways to put the start a string, and then there's n ways, roughly speaking. I know it's n choose 2-ish, to choose the n that's after the start. And so there's n square string, and it takes another n to kind of check if it's a palindrome. You can actually do better than that, but with n is equal to 16, I'm going to just leave it at the n cube algorithm so that we could focus on what I think is the hard part for now, which is the 2 to the n part, right? Which is backtracking or recursion or whatever. There's different ways to do it. And actually, I would also say that just for future maybe upsolving is that in this case, you have to do a backtracking e thing anyway, because n is equal to 16. N is equal to 16, so you could do it and it's fine. But also because you have to output the exact things anyway. If you're given the problem and they just want you to ask the number of ways to do it without outputting the paths, then you may be ahead of me. And in that case, you could use dynamic programming. And you could use dynamic programming because you could just keep the count at each cell, right? And also for additional upsolving is, or at least getting more theory into your head, another way to think about it is, about this problem, to solve similar problem, is that, okay, let's say there's now I'm going to add a bucket to the beginning and a bucket to the end. And, you can ignore what I said earlier first for now. But basically, you're trying to get from this bucket all the way to the end. All the way to the end. So you're trying to get from the leftmost point to the rightmost point, where there are edges. There's an edges if it's a palindrome, right? So let's say that, this goes to palindrome, then there's an edge here, goes to here. And there's always edges of length 1, because 1 length strings are always palindromes, right? So stuff like that. And if you kind of write it this way with respect to edges and stuff, maybe you recognize that this is actually a DAG. And this also goes with the dynamic programming, but also another way to formulate this problem is going from the beginning to the end. Count the number of paths going from the first node to the last node. And that's actually a problem that comes up from time to time, depending on the formulation and stuff like that. And so it is something that is definitely worth practicing as well. And actually, if so these are just upsolving. I'm just going over things that you can upsolve for this problem. But in this case, the less interesting part is that after you come up with the fact that this is going to be 2 to the 15, or 2 to the n, and maybe n cubed plus 2 to the n. Once you come up with that, the implementation is not as interesting for me. But now we're going to start doing it. And because I called it uninteresting, I'm probably going to get like 5 wrong answers, because that's how karma works apparently, especially when I'm on stream. But yeah, definitely try to upsolve it and figure it out. So I'm going to write the cache for now. So yeah. How do I want to write the cache part? Okay. So so yeah, let's just for start in range sub n, let's say n is equal to length of s. For n in range from start, I guess it could include start because you got 1 length once. And then it's just a symbol if palindrome or is palindrome. S of s to n, I think. I always get confused. Then we draw an edge from start to n plus 1. Okay, so how do I want to do that? Well, let's just go cache of start of n is equal to true. Or n plus 1, because and could be the same character, so it's meant to be exclusive. But I gotta make sure that this is right. I always forget how substrings work in or sub-slices or slices work in Python with respect to that. So we'll double check that. But yeah, so now we need two things, which is palindrome string or word say, and I'm just gonna write it lazily, right? Is you go to reverse subword. Except for we have to join it back to a string, and we also have to write the cache, which is force times n plus 1 for range of n plus 1. Okay, right? Okay, so basically here we have an n cube algorithm to pre-cache the palindrome, right? So yeah, so this is basically off my head. There are definitely optimizations you can do. You can actually reduce this to n square, and if you have, fun time, I would recommend that. So now we're able to do what we said, which is a recursive port. And what do I want to call it? Let's just say construct. Naming is hard. Definitely work on your wording. Work on your naming. But yeah, let's keep track of the current array, or like the progress array, and character index. Let's put the index in front, and then it goes to the end. Okay, so now we have an answer that I just put outside for, yeah, just for being easy. But in theory, if you want to do it cleaner, you just return stuff and then construct them together. But technically, I think this is actually safer. It's okay. So if index is equal to n, I think. Yeah, okay. I just want to think whether this needs to be n or n plus n minus 1. If this is the case, then let's append the current array to answer, and then we return. One thing to note, and sometimes I don't go over it because I forget, is that current array is going to be a reference because it's an array, or I know it's a value to the pointer to the array, or the memory address of the array if you want to be specific. This is Python specific though. For some languages similar. So if you just append it without what I did here, you're going to append the pointer, and then and all your answers are going to look the same. I'm going to leave this like this actually, just to show you later. But note that this is why I had this here. So that what this does is that it makes a copy of the entire array. So yeah, so that's basically why I do that. If you look at the syntax, I'm going to remove this, and then I'm going to forget it by the time I get to it, so that just so you could see why that see what happens when you do it. But anyway, okay. So if it is not n, then okay. Do we look at the current array? Yeah, okay. So basically now we do another loop. Do we want to do another loop? There are two ways to do it, I guess. Okay, I'll do it the other way. I think it just becomes an implementation detail. I think it's the same either way. Current construction, say. And then now we have to change a thing where if current is equal to empty, because if current is not empty, that means that something messed up somewhere. Or not messed up somewhere, it's just that we forgot to put the partition at the last one, which we should. So I could have also used the last element of the current array, but I feel like this is maybe cleaner, maybe, I don't know. But yeah, so now for each index, we choose to either, the two things we can do, right? We can either current add, I mean, I know what I want to represent, but I think I'm just have to make sure that I'm getting it correct. So something like this, so that this adds it to the thing. Is this the way that I want to code it? Just think about implementation wise. Current array. Okay, yeah, I know what I want to do. Sorry. So yeah, so now new current is equal to current plus s of index. So this is now the new current array. And then now we choose to either end this here, meaning, now we have a new empty string because we ended the string, and then current array will just, add a new element of new current because we append it, or we just keep on going with the current progression and not put a string. So this is new current and then still current array. Hope this is makes sense. But basically, this one is we do a recursion. We start, we cut it off. That means that so we put the new current into the current array as a new element. In this case, well, we just keep on going. So yeah. And I think this should be okay. I mean, we have to actually call this in the beginning, which is construct 0 empty array. I mean, empty string and empty array. And then let's give it a go. Yeah. So again, oh well, I missed something silly, which is that we have to make sure this is a palindrome. So actually, it is wrong in a number of ways. Huh? This is surprising. Well, I know why this is reacting not what I said with the copy array, even though I think you should do it in general. It's because here I reconstruct a new array every time instead of append. So it depends on how you want to do it officially. And the way that I did is that apparently every time I add a new element, I create a new array, which is actually way less efficient. But then I also don't, oops, how did that happen? But then I don't have to remove the array after this to do the recursion. So but in any case, yeah, as you can see here though, this basically is what I want to do. It is not the right answer because we don't filter out the palindrome stuff, which we can do it quickly, but I want to check real quick how it looks on 16 things, and this is going to be the worst case if we do a palindrome, if we just split it at every time, right? So yeah, definitely going to try some time here. Maybe this ends up taking too long because oh no, it takes, wow, it was only 350 milliseconds. So that's way fast enough. I guess it's just taking a long time because it's trying to print out the output. So okay, so then I'm not going to, like I said, and this is obviously not the right answer because I print out way more because I don't filter out non-palindromes. But I also want to see the performance of the worst case, just in case. So I mean, we did the analysis, so we're happy here. Okay. So I guess the other way to think about it, instead of having a current string, which is, well, it doesn't help us with the lookup. We should just go with the start index, which is the same thing, really. Oops. So let's start here at the 0 as well. Maybe -1. This is an awkward start index, but yeah. So then now we can check if cache of start index and current index, if this is a palindrome, then we can use it, right? I'm also worried about off by ones, to be honest. Let me think about this for a second, because this comes up a bit. If this is good, then we can construct a new we could add it to a new element. So then now we start at index +1 in that case, and just current array plus the new string, which is now just, what's that word of start index to index. I always forget if the second one is a character or not, but okay. And otherwise, no matter what yeah, so this is only when we take it out. Am I missing a case? I feel like something's a little bit weird. Oh no, this is an ongoing thing. Otherwise, or not even otherwise. Give me a second, man. I think I lost my train of thought for a second. This is what happens when you solve these things live sometimes. Okay, so I mean this part is right, but now what we want is just in general where we want to start a new word here, right? Because if we're able to get to here, that means that this is a new word. So did I mess up? I think I'm getting a little bit confused with my indexes. That's my confusion here. Oh yeah, I think I just missed a case in my original thing. That's what. No, I mean, it looks okay. That's a little bit weird then. Let's try this. So I think this should work, except for that now, the current array doesn't make sense. Oh, I know why. I'm just trying to translate from my old thing. But yeah, but now here I have to do index of index. So basically like one character. Hopefully that's right. Oops, word is not defined. What is it called? S? Current is not defined. Where do I use current? Oh, oh yeah, we don't use it anymore. Do this still needs to be done anymore? No, I guess not, right? I feel like I'm gonna have an off by one somewhere, to be honest. So, so we'll see. Let's give it a go. Well, that's a little bit sad. I mean, this should at least always give us something, but yeah, why isn't it at least giving us a one character answer? Did I not do this right? What is? Well, let's put. Oh, maybe I just. Like I said, maybe I got the string part confused. What does? Is this from string from 1 to 2 or something, or how does that work? Okay, let's just print. I might be very confused about how the slices work. That was my laziness. Okay. I don't. This actually doesn't help me in describing this, but let's do start n. But definitely have spaces that I wouldn't like. For some reason I thought that if they're the same, that would have at least one character. So, okay. So basically, n is not inclusive. Okay, so that's the part that I wasn't sure, that I'm clearly wrong on. For some reason, I thought it would be inclusive, but it is not. Okay, fine. Okay, still wrong, huh? Yeah, my original recursion is good, but I didn't check the thing to use the cache. Let's put out the cache real quick. I'm a little bit silly right now, just to make sure that it works. Okay, so it definitely works for some stuff. This is from the 0, so 0 to 1 works, so that's just one length. Right, okay. Yeah. So basically that's what we want to do. So why maybe the start index is a little bit weird. Let's take it out for a second. Uninteresting problem. I knew this was gonna happen, right? Okay. So this looks better from here. Oh, that's why. This needs to be index plus 1. Okay, off by once because I wasn't careful with how I used it. But and I misspelled construct. That's okay. That's an easier to fix problem. Yeah. At least that means it's printing something. That's why judging is so slow. I should have taken this case out. Okay. So this is better, but still not great. Okay. But the reason why is because start index and index could be the same, and we do loop twice. So, so yeah. Okay, so we could just add an if statement. I mean, that doesn't matter, but if star is not equal to index and this. But this is only because we double counted in both cases. So yeah. Ooh, wow, still in. Huh? Did we? That is man. That is weird. Is it now because, let's do this. No, that doesn't make sense, right? Well, we definitely need to do that in any case, but... Well, the start index is weird. I mean, I definitely mess up somewhere because we always do index plus 1. So I need the start index to be index in one of them. Yeah, because we want to start the index here. Okay. I think I was just translating the code wrong. And then here, I guess we don't need it anymore because that doesn't make sense anymore in context. Because those are not there shouldn't be overlap. I think I was just a little bit confused, clearly. And now this short video is way too long. Okay. Oh yeah, then now we have to go back here and we have to add the if start index is not n, then we could do it. Otherwise you have these dangling things. Oh, this is equal to n. Whoops. It's late in the day. Okay, so that looks good. Let's try some other cases that doesn't blow up my timing. And do I have to do empty strings now? Okay, fine. And we already have one. This is good. This looks good. Let's give it a submit. A little bit tired, and this shouldn't be even that hard. I talked a lot for this problem, but oh no! Huh? Maybe I went off by 1 somewhere then. How? Because of this thing. This thing, I mean. Also, ironically, if I did it without the pre-calculation, I would have gotten right already with the way that we did it the first time. But I think I'm just messing up some state somewhere with our off by 1 somewhere, which is unfortunate. But, you know, that wasn't even that. How did this happen? Oh no! I misread the output. This is actually just doing more, right? Like for some reason I thought that the expected answer has this, but we were missing it. But now that I see that we actually had an extra thing, now I'm confused. How did we start from there? Do I have an off by 1 somewhere? How does this even get constructed? There should not be a way for start index to get to from 0. Right? That is weird. Like, how did... I mean, I have a typo somewhere, clearly, or off by 1 maybe, but that's sad. I'm sad. This is what happens when you upsolve stuff live. Okay. So this is concluding a string. How do we get here without a C? All right, let's just print this out progressively. I mean, okay, so this is added last. But how? How? Like, how did this current array became this? That is odd, isn't it? Isn't it? Let's do this before auto recursion. How do we get from 1 0? 1 0 0 is 1's okay. How do we get to 1 2? Oh, Wait, what? How do we get to 1, 2? Oh. Oh, this is just silly. It should be the start index because we've not. What this is doing is that we're adding it to the current start index. But oh, that means. Okay, there we go. Oh, I should have tested the other cases first. I'm gonna get another wrong answer anyway. Okay, fine. Whew. Okay, so a lot of silly mistake on that one. And that's. I would also say that that's half because I try to rush through it. You saw a couple of off by ones. I think if I respected this problem more, because maybe it's because I said it was uninteresting in the beginning. If I respected this problem more, I would pay more attention while I'm doing it and going through it just to make sure that I have all the off by ones okay. I actually don't even know how this video is 30 minutes, but yeah, what's the complexity? Again, we already did the complexity. What's the space? Well, it's going to be 2 to the n because times n, because that's the number, that's the size of the output, right? Meaning that no matter what, you have to print that out. It's going to be n times 2 to the n at the worst case, plus n squared or n cubed. Oh, no, this is n squared for space. So yeah, let me know for this problem. This is a long video. Let me know what you think, and I will see you tomorrow. Bye bye.